This is our patellar stretch reflex device. The main objective of this device is to quantify the time between the tapping of the patellar tendon on the kneecap and the activation of the rectus femoris. This test is traditionally used by pediatricians to get a quick glimpse of spinal pathway health, and lack of response time can help make an early diagnosis of possible neuromuscular diseases. Typically, this test is a subjective measure, but we have created a system to allow for a quantifiable measurement. Utilizing a pressure sensor on the tip of a medical percussion hammer, we created a code that started a timer when the hammer came into contact with the kneecap. Electrodes were placed on the surface of the rectus femoris muscle in the quad, and once muscle activation was detected, the timer stopped. The microcontroller was then programmed to print out the reflex time in units of milliseconds. The circuit for this device consists of 3 stages: amplification, filtering, and a full-wave rectifier. The first stage of the circuit consisted of an LT1167 operational amplifier, which we set to have a theoretical gain of 100. The second step was filtering. We used the UA741 to build an active bandpass filter with a theoretical gain of 34, giving the first 2 stages a total gain of 3400, which we found to be necessary for the 0.09 to 0.24 millivolt signals from the quadriceps muscles. And we utilized a bandwidth of 4.8 Hz to 480 Hz to filter out unwanted noise. For the final stage, we changed the AC signal to a DC signal using a full-wave rectifier. This stage did not have any gain, and the output of the circuit was inputted to an analog pin on the Arduino to be monitored. The pressure sensor on the hammer is part of a separate circuit. We found the resistive values of the pressure resistor to decrease from 2.6 mega ohms when the sensor was untouched to 600 ohms when the pressure was applied. Because of this, we then created a simple voltage divider using a 1 mega ohm resistor. Using a 5-volt input, the output of the circuit will then be 1.38 volts when the resistor is untouched and 5 volts when the pressure is applied. The system overall seems to be successful. One potential problem with the design is that it sometimes takes several hits in order for the pressure sensor on the tip of the hammer to activate. This could be due to the quick contact time of the hammer not correlating to when the analog pin is being read, or it could be the actual pressure sensor not changing resistance in the quick contact time. We adjusted our method of the test to use a slightly more sustained hit to the kneecap rather than the quick tap that is more traditional to the patellar reflex test.